Thank you once again, as we have covered the theoretical view on the hypothesis testing. Now it is a time also to look for the practical side of hypothesis testing so that we can understand what it means. So this is also some practical applications we can do in inferential statistics, or especially for hypothesis testing before we go to the advanced model. So we are trying to understand the assumptions that we normally set. So those are also some definitions, and we have seen that hypothesis testing, it is also in two types, where we have a null hypothesis and the alternative hypothesis. And the null hypothesis says that there is no effect or no difference. That is what we normally know. And alternative, there is an effect or the difference. So that's what we are going to look for. Here we created the sample data. We have group A. So here we have a group A. We created the observation, just a dummy observation. Here is a group A and a group B. And we have the paired sample before and after. We are trying to generate the data so that we are going to see two sample t-test and one sample t-test. We create the before observation and after observation, and also before we started doing analysis, we have seen that we normally have to start doing the test before starting doing the t-test, p-value, sample t-test, those kind of tests that we are running to check for the hypothesis. We started on checking the normality by using Shapiro.test. That's what we are saying. And the null hypothesis of Shapiro.test, it is saying that the data is normally distributed. They share common characteristic. That's what it means. And then the alternative hypothesis says that data are not normally distributed. So since we run the Shapiro, and then once we get the p-value which is greater than the level of significance, by default the level of significance is 0.05. So here we said we don't have enough evidence to say that the data is not normal distributed. It means that since we failed to reject the null hypothesis because the p-value is higher than the level of significance, we conclude that the data are normally distributed because we don't have enough evidence to reject the null hypothesis. Again, to group B, still the same. Group A, group after and before, still the same. Those are also the Shapiro test. And now we can proceed since we have our data which is normal. So if we see that the data is not normal, so we are not going to proceed. We are trying to look for the other test so that we can normalize our data. So we are going one sample t-test. We are testing if the mean of group A is equal to 85. So let's say if I say t.test, those are the things. So since we get this result, this is the t calculated. You see, this is also the t calculated, and this is also the t calculated. So this is the group A, this is the t calculated, and when we are trying to make the conclusion, as I said, we normally look for the p-value. So this is also the p-value that we are looking for. So since we have seen the p-value is this, either for the sample t-test, either for the paired, whatever that we are looking for, since we have p-value which is greater than the level of significance, it means that we failed to reject the null hypothesis, which means that the mean value is not equal to 85. So we rejected, and we failed to reject the null hypothesis by saying that since the p-value is greater than, we failed to reject the null hypothesis, which means that this is equal to this. So that's what it means. And once we are proceeding on this, we are going to see if two sample t-tests, we are trying to test if the mean score of group A and B are the difference, and then we see that the p-value, it is also still greater than this, and then the true difference mean is not equal to this is what we have. The alternative hypothesis, the true difference mean is not equal to this, which means that there is a difference. So since we get this, this is also the confidence interval, and this is the t calculated, and this is also the t statistics. So that's what we have to consider. And the same as to sample t-test, sample pair t-test. So those are also the kind of things that we can look for. And those are also some non-parametric stuff, but we are not going to take much time on it. And also there is a lot. So what we have to do, it is just to master this, and note that before doing any kind of analysis, so what you have to do, it is just to understand what you are doing, and make sure that you consider it, or you take decisions based on the what statistics also provide to you. And another thing, you will see a lot on this practical code, like where you will see some non-parametric test. The non-parametric test, it is somehow advanced, and it is not most of the time the popular for those kind of hypothesis testing. That's why I put the non-parametric statistics, so that you can be aware that there is existing. The non-parametric test, it is where the data is not normally distributed. If you run Shapiro dot test and you see that the data are not normal, so it will guide you to the non-parametric testing. So that's why I brought non-parametric, and it is new for you, and which is not a problem. So if the data is not normal, use non-parametric test like man-Witten t-test, and then you will read a road on this. This is also the extension, another extensions of how you can perform, either if it is one sample t-test and yet you was like seeing that you were like seeing that the data are not normally distributed. Instead of stopping it, you have to jump to the non-parametric test. And we have seen also you will see the chi-square. So where the chi-square is trying to check the if there is association between two categorical variables, like between gender and the past. So that is also association between two categorical variables. We use chi-square, and then this is also the chi-square. We have gender and the past. We want to see if there is a difference between male and female in terms of pass or fail. So this is also what is going to bring for us. And once we do the chi-square, we do the chi-square by looking for the p-value and the level of significance. You see the p-value is high. It means that we failed to reject the null hypothesis, which means that there is no difference between the pass and the fail between male and female. So both male and female are equal. Those are the correlation test. We are trying to see if there is the relationship between two variables, which is also numeric. Looking for the relationship between two continuous variables, we are using also the correlation analysis. We are trying to see if this x and y has the relationship. We do correlate and dot test. We put x independent variable and the dependent variable method. It is Pearson and also Spearman. We are looking for non-normal data. So Spearman, it is when the data are not normal, but what is going to show you if the data is normal or not, you have to run Shapiro.test. You have to run Shapiro.test before doing any kind of test that we are having here. But if the data it is normal, the correlation test that we are going to use, so that we can confirm if there is a relationship between two continuous variables. Of course, we use Pearson correlation or also Spearman correlation. So those are the kind of things we consider one way while you are trying to use the correlation analysis. And also those are the summaries of the functions we have used. There are Shapiro.test, normality check, t-test for one sample, two sample, and pair t-sample. Wilcoxon, those are Wilcoxon test, non-parametric alternative. Once you see that the data are not normal, there is also another option to jump to the Wilcoxon non-parametric. And chi-square, it is for association between two categorical variables. Correlation, it is also looking for the relationship between two numerical or two continuous variables. So always checking the normality before doing parametric test, it is also important, and this is also the practical examples I provided to you so that you can continue to enjoy the rest of the session. Try to do the practice as much as you can, and feel free to ask any kind of questions that you are not understanding very well, so that will be easier for you to master hypothesis testing before also going to the regression analysis or other techniques like machine learning. So you need to understand